The lecture order of the chassis is as follows: system introduction, manual transmission, electric four-wheel drive, and self-levelizer. First, let's study about the chassis system of the new Santa Fe. The new Santa Fe has two manual transmissions, M5 GF2, which is already used in the NF Sonata, and the M5 HF2, which is a new one. CSC, SAC, and DMF systems are also applied. For auto transmission, A5HF1 and F4A51 are installed by engine types. Those two auto transmissions are already used in previous Hyundai Motor Company vehicles. In the case of the D2.2-liter CRDI engine with A5HF1, the TCM is not the PCM type. A separated Melco TCM is used. The ABS is a standard specification, while ESP is optional items from Bosch 8 version. This Bosch 8 version ESP system is also adopted in the NF and TG before. For the component's location, the yaw rate and lateral acceleration sensor are installed at the central lower side of the center fascia. The CAN communication type steering angle sensor is installed at the lower part of the clerk spring. The four-wheel drive system is the electrical variable type four-wheel drive of Borg-Warner. As the electrically adjustable pedal is installed as an optional item, it can help to maintain the driver's condition conveniently. The feature of the adjustable pedal is that the adjustable pedal relay and the twin relay are installed in the ICM relay box. This unit is installed at the left of the center fascia. Most systems are the same with previously applied Hyundai Motor Company vehicles. We will explain mainly about the newly applied items with big changes. The new M5 HF2 manual transmission is used in the D2.2-liter CRDI engine. In case of the Lambda 3.3-liter gasoline, only auto transmission is available. The main feature of the M5 HF2 is a three-axis structure like previous M5 GF2 to enhance the torque capacity and endurance. At the shift control lever, a reversing switch and a neutral switch are installed. The transmission oil is the SAE rate 75W85 of viscosity, so that the shifting is smoother than the old one. Further, a new shifting pattern is applied, so that the operation becomes easier than before. At the clutch control system, the CSC is applied mechanically. It is the same with the NFs. Using CSC, the clutch controller can be the single module so as to enhance the operating efficiency and to lessen the part numbers and weight. To remove the CSC and the hydraulic hose, remove the clip and then pull the quick connector of the hydraulic hose. In addition, the self-adjusting clutch, SAC, keeping the stepping force of the clutch pedal evenly, is also applied. The components of the SAC are the clutch cover, the adjuster ring, the stopper, the diaphragm spring, the sensor spring, the pressure plate, and clutch disc. For the general clutch system, when the clutch disc is worn out, the diaphragm spring would be erected up so as to increase the stepping force of the clutch pedal. By the same process, in the SAC system, the stepping force of the clutch pedal is also increased. However, by the operation of the sensor spring detecting the increased stepping force, the diaphragm spring is moved to the disc side, making the adjuster ring fill the space. Therefore, the diaphragm spring can maintain the initial clearance. Further, the stepping force of the pedal also maintains the initial force. As shown in the single device picture, to check the disc worn condition, look at the compensation spring. Now, let's study about the cautions at maintenance service. First, when installing the clutch, the TM side facing to the clutch cover should be positioned. Second, when replacing the clutch, replace the clutch cover and clutch disc as a set. Because the clutch cover is adjusted with the worn amount of the clutch disc, if the worn clutch is replaced only, then the disc slip can occur. Third, when assembling the clutch cover, tighten the bolt and nut in sequence. These should be fastened with regulated torque by applying the torque dividing at a 2 to 3 at each bolt. If each bolt is fastened at once with one time, the cover may be distorted so that the pedal's stepping force may be increased or the clutch may make a judder. Finally, as the CSC, SAC, and DMF may be defected by a shock, be careful when carrying them or working with them. The four-wheel drive ECM is installed at the lower center portion of the passenger seat. It determines the road and driving conditions using various sensor signals sending to the four-wheel drive ECM. It precisely controls the driving force is transmitted to the front and rear wheels, which can be various. For the improved items from the previous Santa Fe. First, with the same size of coupling, the capacity is enlarged. Second, the function of the lock mode is improved. In the conventional form, under the four-wheel drive lock mode with driving in full turn, the tight corner braking phenomena occurred due to the rotational radius difference between the front and rear wheels. The new Santa Fe is applied with a different logic control. If you select four-wheel drive lock while driving in a full turn, the duty controlling the magnetic clutch is various by the steering angle to prevent the TCB phenomena. As the angle of the steering wheel is increased, the duty valve of the EMC coil is gradually decreased. In addition, there are some new DTC codes added. For more detail, please look up the relevant workshop manual. At the rear wheel, the self-levelizer controlling the vehicle's height automatically according to the load is applied. Due to the SUV characteristics, the load applied to the rear wheel are always varied according to the passenger's number and amount of packages. The self-levelizer is to compensate for the deflection on the rear wheel when loading to enhance the vehicle safety. Within 2 minutes after driving over 2 to 3 kilometers of speed, the leveling is completed. The components of the self-levelizer are the piston rod receiving the load of the vehicle directly. At the piston rod, there is a piston valve, generating dampening force as the shock absorber. The pump rod comprising the release hole making a role of a sensor for the vehicle height, the leveling position, and the pump chamber. At the upper portion of the pump chamber, the outlet valve is installed. At the lower portion of it, the inlet valve is installed. Low pressure reservoir making a role as the oil tank for pumping, and the high pressurized chamber making the spring force using the increased gas pressure according to the pumping. Further, a relief valve preventing from overpressing in the chamber is installed. The operating principle is as follows. First, at the initial state without load, like the general shock absorber, the dampening force by the piston valve is only made. Leveling is not working. At that time, the release hole linking the high pressurized chamber and the low pressurized chamber is opened. Second, at the load applying state, the release hole is closed so that the high pressurized chamber and the low pressurized chamber are divided. Third, according to the road condition, if the piston rod is pulled, then the volume in the pump chamber is instantly increased so the pressure is lowered. Then, the oil in the low pressurized chamber flows into the pump chamber through the inlet valve. Hence, the pump chamber is filled with oil. Fourth, according to the road condition, if the piston rod is compressed, the volume in the pump chamber is instantly decreased so the oil pressure is increased. The pressed oil flows into the high pressurized chamber through the outlet valve. Due to this oil, the pressure of the high pressurized chamber is increased. Fifth, as the pressure of the high pressurized chamber is increased, the leveling is working with the load corresponding to the increased pressure. Hence, the piston rod is pushed up to the upper side. If the piston rod is elevated over the leveling position of the pump rod, the oil is leaked out so that the more pumping is not occurred. Hence, the level of the vehicle is maintained constantly. Finally, after the leveling is completed with loads, if the loads are unloaded, then the vehicle's height is instantly elevated and the release hole is opened. Then, the pressed oil in the high pressurized chamber flows into the low pressurized chamber. Hence, the level of the vehicle returns to the initial state. The standard level is the distance from the wheel arc to the center of the wheel cap. The standard level at the curb vehicle weight is 465 millimeters plus or minus 10 millimeters, and the standard level at the gross vehicle weight after completing the leveling is 445 millimeters plus or minus 10 millimeters. Up to now, we have studied about the chassis for the new Santa Fe.